Next, my favorite kind of story in life is the kind that reminds us that we are nowhere near as close to as smart as we think we are.
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart.
More than anything else, I love stories that remind us how little we really understand, especially when the universe throws us a curveball.
And right now,
the James Webb Space Telescope just pitched one at the speed of light. For months, astronomers have been poring over a new deep field image that Webb captured, and what it shows has quietly set fire to the foundations of modern cosmology. At the center of it all is one galaxy, impossibly old, impossibly massive, and impossibly structured. A galaxy that, by every model we've ever trusted, simply shouldn't exist. And then Michio Kaku, physicist, author, and one of the loudest voices in theoretical science, finally spoke up. He'd been silent during the initial speculation, but when he finally gave his take, the conversation changed. Because what Webb just photographed might not just shift our understanding of galaxies. It might force us to question the nature of time itself. This isn't clickbait. This is real. The image in question shows a galaxy so distant that its light began its journey toward us over 13.5 billion years ago. That puts it close to the beginning of everything. We're essentially seeing it as it was just a few 100 million years after the Big Bang, a time we've long assumed was chaotic, raw, and still taking shape. And yet this galaxy is finished. It's huge. It's stable. It has spiral arms. It has what looks like a central bulge, the kind of feature that normally takes billions of years to form. But somehow, there it is, frozen in light from a universe that was supposed to be too young, too wild, too fresh. And here's the kicker. This isn't the only one. This is just the best resolved example so far. Other ancient galaxies spotted by Webb are showing similar maturity. Too early, too fast, too massive. They're not supposed to be there. The Lambda CDM model, our standard map of how the universe evolved, says these galaxies should be small, disorganized, still forming. Instead, they're fully built cities floating in ancient space. Kaku called this not an anomaly, but a signal that something fundamental is wrong with our assumptions. And when Michio Kaku says that, you listen, he didn't just suggest we need to rewrite the galactic timeline. He hinted we may need to rethink what time even is. Because if galaxies like this were able to form so quickly, that means either the forces shaping the early universe worked very differently than we believed, or we're missing something completely. Something huge. One idea being revisited is that space-time itself might have evolved differently in the early universe. Maybe the process of inflation, the period right after the Big Bang when everything expanded at incredible speed, seeded these galaxies in a way we haven't accounted for. Maybe dark matter clumped faster. Or maybe forces we haven't discovered yet played a role. There are even whispers about something deeper. That these ancient galaxies aren't just old. They might not even fully belong to our universe. It sounds crazy, right? But some of the more cutting-edge theoretical frameworks, like brane cosmology or aspects of string theory, allow for interactions between parallel universes. Collisions, overlaps, cross-contamination between realities. If that sounds like science fiction, just know, it's math. It's in the equations. We just never had a reason to take those interpretations seriously, until now. What makes this even more fascinating is how Webb is capturing this data. Unlike Hubble, which focused mostly on visible and ultraviolet light, the James Webb Telescope is designed for the infrared. That means it can see older light, redshifted light that's been stretched by the expansion of the universe. It can cut through cosmic dust. It can see things no human eye ever could. And what it's seeing is not what we expected. These galaxies aren't smudges or blurry clumps anymore. They're detailed, defined. Their structure is undeniable, which is exactly what makes this so disruptive. One argument that some scientists floated early on was that maybe redshift isn't telling us what we think it is. Maybe these galaxies aren't as far away and therefore as old as they seem. But the data says otherwise. Every wavelength, every signal Webb picks up, confirms the same thing. These galaxies are ancient. And they are wrong. Gloriously, beautifully, dangerously wrong. Kaku didn't downplay any of this. In fact, he said it straight. This could be our Galileo moment. Just like when Galileo's telescope forced humanity to accept that Earth wasn't the center of the universe, this new view might force us to accept something equally uncomfortable, that our entire model of cosmic history may be fundamentally flawed. That we've been looking at a map of the universe drawn in the wrong scale. And here's what makes that so exciting. When models break, discovery begins. Already, new theories are being built to explain what we're seeing. Some suggest that early pockets of matter might have evolved more quickly than we thought due to quantum fluctuations in the first few milliseconds of the universe. Others propose that gravity might have behaved differently in those high-density environments. Or that dark energy had an opposite effect early on, acting as a catalyst instead of a repellent force. But perhaps the most radical idea is this: what if the universe isn't homogeneous at all? What if there are regions, vast, ancient, scattered across space, where matter evolved faster, where time flowed differently, where physical laws flexed in ways we don't yet understand? If that's true, then we're not just looking at new galaxies. We're looking at new rules. Now imagine for a moment that time itself isn't a universal constant, that in the furnace of the early cosmos, time could bend or flow differently depending on energy density or particle interactions. In that case, some regions of the universe might have developed at warp speed, leaving behind galaxies that look like they're billions of years old, even though they formed just hundreds of millions of years after the Big Bang. That possibility doesn't just challenge cosmology. It tears open new doors in physics, quantum theory, and even consciousness studies. Because if the passage of time can vary that dramatically, and if our instruments are only now catching glimpses of these distortions, then everything we assumed about cosmic evolution needs to be recalibrated. Kaku didn't shy away from that implication. In his view, these findings push us toward a more multidimensional universe. One that may include hidden variables, forces, or dimensions we've never observed because we never had a reason to look. Until now. He floated an idea that stuck with a lot of people. Maybe this galaxy and others like it didn't evolve in our universe at all. Maybe what we're seeing is bleed-through from another brain, a separate slice of space-time brushing up against our own. It's wild. It's controversial. And it might just be true. Because what Webb has delivered isn't just light from the past. It's evidence. A direct challenge to the story we thought the universe had already told. Some scientists are already adapting their theories. There's new energy around ideas like dark radiation, exotic particles that may have seeded early structure. Others are revisiting inflation models, asking if the Big Bang wasn't a smooth expansion, but a chaotic burst that created isolated bubbles of rapid galaxy growth. All of these theories were once on the edge. Now they're being dragged into the center of the conversation. And that's the real power of this moment. Because this isn't about a telescope. This is about the edge of knowledge, that razor-thin boundary where science stops being comfortable and starts being real again. Where data stops confirming what we believe and starts telling us something new. Something we didn't ask for. Something we might not be ready for. The James Webb Space Telescope wasn't built to play it safe. It was built to challenge us, to force us to look farther, think deeper, and accept the possibility that the universe is stranger than we ever imagined. And it's doing exactly that. Just think about the tools we have now. Webb doesn't just take pretty pictures. It analyzes the composition of galaxies billions of years old. It reads the fingerprints of elements in their light. It tells us what kind of stars were burning, what kind of dust was forming, even what kind of chemicals were floating in the air of alien worlds. And yet, in all that power, the most shocking revelation has come not from what we were trying to find, but from what we didn't expect. This wasn't a mission milestone. It wasn't planned. It was a discovery. And that's how science moves forward. But there's a more human side to this, too. One that doesn't fit in equations or spectra or light curves. This discovery shifts the psychology of exploration. It reawakens something primal, that sense of awe and fear and wonder, that feeling that the universe is watching us right back. Not as the center of anything, but as participants in something so vast, so intricate, so impossibly old, that our only true role is to try to understand it, one photon at a time. It's no longer just about where we are in the universe. It's about what kind of universe we're in. Maybe we're not in a single smooth cosmos, but a fractured, layered multiverse. Maybe these galaxies are clues, relics from a universe next door, or signals from a timeline that branched off from ours before we were even atoms. And if that's true, then we've only just begun to scratch the surface. This is the part where the world catches up. Expect to see a wave of new theories, new debates, and new missions proposed over the coming years. Expect scientists to argue over details, dispute redshift models, and fight for telescope time. That's what science does when it's alive. But more importantly, expect this image, this one impossible galaxy in the depths of space, to become a turning point. Not just for cosmology, for all of us. Because it doesn't matter if you're a physicist or a poet, a kid watching stars from your rooftop, or a philosopher questioning the nature of being. This discovery touches everyone. It forces us to ask where we came from, what we're part of, and what else might be out there, just beyond the veil. This is how revolutions start. One image, one impossible structure, one question science can't yet answer. And maybe, just maybe, the real value of Webb's discovery isn't what it shows us. Maybe it's what it makes us feel again.
Curiosity.
Humility. Wonder. That sense that the universe, in all its incomprehensible beauty, still has secrets left to share. If you like this video, please give it a like and subscribe to our channel. Also, leave your thoughts down below. What do you think this discovery means? Do you believe the timeline of the universe needs rewriting? Or is there something even stranger going on? We want to hear from you. Thanks for watching. And remember, the sky is no longer the limit.